Hello everyone, my name is Snehaaigali, student of Sri Venkateshwar College of Engineering, Bangalore. I'm studying in fourth semester and today I'll be explaining you guys about discrete mathematics for CSE stream. In that particularly, we'll be discussing about introduction to group theory. Well, before briefing about group theory, let us first understand what actually group theory means. Group theory is a branch of mathematics that studies the properties of groups. A group is a set equipped with an operation that satisfies majorly four fundamental properties. Groups are used in various fields which include physics, chemistry, and most importantly is our computer science. Next up is definition of group. What a group actually means. Group is a set G with a binary operation dot, that is, we use a dot operation that satisfies certain properties which include closure property, associative property, identity property, and inverse properties. Now, here we have explained about this. We have equations for closure property and associative property, in which first up is the closure property, which states for all A and B in G, A dot B is also in G. Next up is our associative property, which states for all A, B, and C in G, that is all A, B, C variables in group G, A dot B dot C is equal to A dot B dot C. Well, next up is the identity and inverse elements. First, let us see about the identity property. It says there exists an element E in group G such that for all A in G, A dot E is equal to A, that is equal to E dot A. Next up, we have the inverse property, which states for every element A in group G, there exists an element B in G, that is in group G, such that A dot B is equal to E, which is also equal to B dot A. The identity element is unique in a group and it has every element that has a unique inverse. That is, every element in the identity group has its own unique inverse. The next up, we have some of the examples for groups, which in which we have the group of integers under addition is a fundamental example of a group. Then we have group of non-zero real numbers under multiplication, which is also another example of a group. Then symmetric groups, dihedral groups, and matrix group are some other examples of groups. Next up is subgroups. Subgroups, which the name itself says, a group within a group. That is, a subgroup H of a group G is a subset of group G that forms a group under the same operation. Subgroups inherits the properties of parent group. That is, a group within a group inherits all the properties of its parent group, such as closure and inverse properties. Every group has at least two trivial groups, the group itself and the trivial group E. Then next up, we have cosets and Lagrange's theorem. A left coset of a subgroup H in a group G is a set AH for some fixed element A in G. We have given the equation for cosets. Then next up is the Lagrange's theorem. Lagrange's theorem states that the order of subgroup H divides the order of group G. Lagrange's theorem has important consequences for the structure of finite groups. You can even see some more description about Lagrange's theorem. You can go through it. The next up we have group homomorphisms. So what does group homomorphism actually means? A group homomorphism is a function between two groups that preserves a group operation. Formally, a function f is to G, which belongs to H, is a group homomorphism if it obeys the condition, that is f of A dot B is equal to f of A dot f of B for all A comma B, that is for all A and B in group G. Group isomorphisms are bijective homomorphisms, implying a one-to-one correspondence between the elements. Now, next up, we have normal subgroups and question groups. A subgroup N of a group G is normal if Gn and into G inverse is equal to N for all G in the group G. The question group G or N consists of left cosets of N in G and forms a group under a natural operation. Normal subgroups play a crucial role in understanding the structure of groups. Next up is we have applications of group theory, where all group theory comes into existence. Group theory has applications in cryptography, quantum mechanisms, crystallography, and symmetric analysis. Other than this, in cryptography, groups are used in design of secure encryption algorithms. The study of symmetry groups in physics and chemistry relies heavily on majorly the group theory. So since we have studied, we have discussed so much about group theory, what can we conclude about group theory? Group theory is a powerful mathematical tool for studying the structure and properties of groups. The concept of groups and their applications have far-reaching implications in various scientific disciplines. Understanding group theory provides insights into the symmetries and patterns that govern the world around us. Well, guys, that was all about group theory in discrete mathematics. I hope this might help you guys. Thank you so much for watching.